Greetings, class. We're on to Chapter 3. And how can we describe a data set? There's many different ways to calculate things that help describe a data set. These things are called descriptive statistics. I have here our data from Chapter 2. These are Henry Aaron's home runs per season for the 23 seasons that he played Major League Baseball. How can we describe this data set? Now look, we can just look at it. It's so small. Remember, the only reason I'm using small data sets is so they'll fit on the video and you can see them all. These same descriptive statistics would work for many, many more pieces of data. And that's where descriptive statistics can come in handy. For example, how many people have blue eyes in the United States? If you had the data set of all the people, no, it doesn't exist, but if it did exist, it would have 333 million pieces of data. You couldn't look at it all. So descriptive statistics, not super useful when a data set is small like this, but we're going to do it anyway because I want to show you how to do them. There's some really simple ones. Count. In a formula, they call this N. That's how many pieces of data you have. And there is, you could count them yourself, there's 23 if the data set is this small. If it's not small, there's a function in Excel that can count them for you. We've already used it, you remember? Equals count, open parentheses, click and drag them all, hit enter. Well, close the parentheses and hit enter. There's 23 numbers over there. In a formula, now I don't use a lot of formulas. American students, a lot of them don't like formulas. They freak out. But in the formulas, it's N for number of pieces of data. What else can you do? You can sum up the numbers in the pieces of data, right? You can only do this with quantitative data. We have quantitative data here. You total. So there's the sum function. Sum that adds up. Click and drag the data like that. Now, Hank Aaron hit 755 home runs, the second highest, or maybe the highest if you don't count people who use steroids. What else could we do? Highest. Now, we can read the highest, it's 47, but imagine if your data set was 300 million pieces of data. You need some computer to search for it. There's a function in Excel. Max. For maximum. Now we know the answer should be 47. Let's hope it's right. What else can we get? Lowest. There's another function. Min. Min is lowest. This should be 10. It is. How about range? Range is the distance from the highest to the lowest. There's a function in Excel. Wait, is the video going? What happened? Oh, it is going. Sorry, I'm a little confused. My computer's somewhat freaking out. The function in Excel, now I think it's range. Now I'm going to have to look it up on my other... I had these written down, you know. My computer is acting up. Okay, I just did some Googling. I don't see a function for range, so we have to manually do it. It's the distance between the highest and the lowest. So what do? Equals highest minus lowest. That should be 37. Well, what else can we do? You remember mean, median, and mode, don't you? Those are measures of the middle. We can kind of see the middle. It's around here, isn't it? The mean is the average. You sum up all the numbers and divide by how many numbers there are, right? So how do you do that? Sum them up. Sum them up. Like that. And divide by how many there are, the count of them. 32.8260896. Now there's also a function in Excel that'll give you the same number. I remember this one. It's called average. So this is another way to do it. If you remember this, it's faster. It should give us exactly the same number as when we did it manually. And it does. So that's one measure of the middle. Another measure is the median. Now the median is if you sort the data from biggest to smallest, it's the one right in the middle where there's an equal number higher and lower. And if there's an even number of data points, you take the average of the two that are closest to the middle. Now we have an odd number of data points, remember, 23. So the middle one will have 11 below it and 11 above it. If we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 11 below, that's 11 above. The median is this one. So you could just look at it when you have a small data set, or thankfully Excel has a function called median. Drag all these numbers. Should be 34. And it is. Now mode is the number that occurs the most frequently in the data set. This data set is so small we can even try to see which one. Let's see, this one appears twice, right? Let's see, this one appears twice. This one appears 4 times. That's the mode. It's amazing. 4 seasons with the dead baseball, 44 home runs, and then 2 higher than that. But so that's the mode, 44. Now here's the thing. There's only one mode in this data set, 44. It's possible, especially in a large data set, you'll have a tie. I made up an example on this other sheet I'm going to show you. I'm going to switch now to a different sheet on this same. You can't see it because it's out of the screen. Wait a minute. I'm going to switch. Oops. Oh, wait a second. Going to switch. Here we go. See down here? I made an example to show you there can be more than one mode. I've made up some fake data. This is not real data. I'm pretending there's an apartment building in an apartment complex or something, and the apartment building has 7 apartments in it. And you decided to figure out how many children live in each one. So these are the number of children that live in each of the 7 apartments. Now if you try to calculate the mode, it's a tie. This and this. 1 children, 1 child, and 4 children. It's a tie for the number that occurs most frequently. That doesn't mean there's no mode. That means that there's 2 modes. Now, can Excel figure that out? It used to be that it could not, but there is a function now called mode mult. I'm going to show you. Mode, you see it? Dot mult, open the parentheses, grab these. It should give us 2 answers, 1 and 4. Let's see if it does. Close that, hit enter. Formula spilled, yes. See, if there's more than 1, it will create, this is called an array when you have more than 1 cell. So it put the formula in 2 places because there's 2 modes. If we had 3 modes, it would have had 3 or 4 or 5 or 6. So when you calculate the mode, you have to be careful and maybe leave space underneath, especially if it's a big data set. You won't know how many modes there are. If you have a big data set, there could be hundreds of modes, you know, if you have millions of pieces of data. So leave some space underneath. Now for this one, we know, because we can see it, there's only 1. So it's only going to show 1. But if we weren't sure, if we had a lot of data and we weren't sure, we wouldn't want to put anything below mode until we did this mode mult. And then grab this. Now it's only going to return 1 answer. But you see, we left some space below, just in case if there was more than 1 mode, it would list all the modes down below. Now it's only going to come up with 1 because there's no tie here. 44. It's an amazing. These were really amazing production of home runs. These seasons here. These are not great, but you know, even these are pretty good for a major league player. Anyway. Now what else can we do for descriptive statistics? We can do quartiles. You know what a quartile is? The first quartile is 25% of the way up. You start at the lowest one and you go up 25%. Now 25, this is 23. In other words, you divide this into 4 equal pieces. Now it's a little hard because it's 23. Roughly speaking, each one would have 5 point something in it, right? So the first quartile is somewhere between 24 and 26. If you divide this into these 23 items into 5, what's 23 divided by 4? Hey Alexa, what's 23 divided by 4?
23 divided by 4 is 5.75.
5.75. So somewhere between here and here is the first quartile, right? Now the book has a formula you can use if you want to calculate it manually. But there is a formula in Excel called percentile inc, okay? That will do it for you. Now, a quarter of the way up is 0.25. So you do equals percentile inc, put the whole thing in. That's what we want it to look at. But what percentile? We got to put a comma. We want 0.25. Like that. And we should get a number between 24 and 26. 26.5. Now that's interesting. This way of specifying a quartile means you're sure that at least a quarter of the numbers are below this. So that's true, right? If you picked 26, only 5 numbers would be below it. 26.5, now at least 5 numbers are below it. We can do this for all the quartiles. Second quartile, that's 0.5. This is the same as the median. Now, the Excel formula might be a little different. The book mentions this, that when Excel calculates percentiles, it might get a slightly different number, but let's see what it says. Percentile Inc. Grab all of the data, put a comma, and that put 0.5. Oh, you don't really need the O, right? Because 0.5 equals 0.50. Let's see what it gets. 34. So this time it picked the middle one. You can do the third quartile. That's 75% of the way up. .75. Third, like third with a D. Let's see. So we do percentile Inc. Grab them all and put comma and then 0.75. 42. So 42 is above 3/4 of the seasons. Now, you might notice that the function I used was percentile. Well, you don't have to just do quartiles, although the reason I do quartiles is because first the book mentions it, and second, it is pretty common. You want to know what number is above 1/4 of the people, what number is above half, what number is above 3/4. Those are nice round amounts. Think about test scores. If you take the SATs, I don't know how long ago, maybe you never took them. Take the SAT, and if it said you were in the 90th percentile, that means your score is better than 90% of the people who took the test. That's really good. You got to be happy about that. Now, if you took the SAT and you're in the 14th percentile, you're only above 14% of the people who took the test. That's not very good. So you can do this for any number. These just happen to be quartiles. We can pick a few random percentiles. Let's say the 90th percentile. That's good, right? This should be a number bigger than 90% of the numbers in the data set. Let's just pick 90th. Equals percentile. Now you got to be very careful. You can't make a dang spelling error, right? Inc. And then grab all of the numbers, comma, 0.9, right? 44 is above 90% of the values. And we could do something like the 10th percentile. This is really bad. Now, by the way, sometimes it's good to be low. If you think about number of times number of speeding tickets you've got in your life, you want to be low on that one. Well, let's look at the 10th percentile. Percentile Inc. Grab all of the data and put 0.10. You got to put the decimal form of the percentile. So, and I should probably put this in parentheses, right? This is 0.90. 14.4. So that is not a very good year for him for home runs. 0.10. And you could do this for any percentile you want. As many as you want. So these are some descriptive statistics. Let's ask Copilot to see what it will give us. Let's put these data in our AI. I have some more to do that are a little trickier than these, in particular standard deviation and variance. I'm going to do that in a different video. So when I ask Microsoft Copilot, it might give us those. In fact, I think it will. But we haven't gone over that yet. We're going to go over that. I'm going to leave the two things called standard deviation and variance for their own video. But let's ask Copilot. I got it open. Here's a data set. Please give me some descriptive statistics for it. So now I'm gonna put the data set in. I don't know what that is, but I put the data set in. Let's see what happens. Submit. I think if you have one of these new PCs that have the built-in it says there's 24 data points, but there's not. There's 23 data points, right? There's only 23. Yeah, I don't want it to look at, I think it's looking at a picture. Let's try again. Please try again. I think it looked at the picture. Yeah, nobody is an expert in AI yet. Now, there are people better than me at it. In fact, well, you might be one of them. Let's try it. I think it looked at that picture. We don't need it to look at a picture. Let's see what we get for this one. Okay, it says there's 24 data points, but there's not. There's only 23. How can it count the number of data points wrong? How can it do that? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23. How does it get 24? This is called hallucinating, you know. When an AI gives you the wrong answer, it's called hallucinating. And it's really annoying that something so simple, it messes up. I mean, I've asked this AI questions and it's gotten things wrong. I asked it how hard it was to climb Mount Lincoln in Colorado. I'm going on vacation in Colorado in July. I'll still be connected to you though by the internet. And it said climbing Mount Lincoln is easy because it's only 8,000 feet. But Mount Lincoln is 14,000 feet. It's more than 14,000. It's like the fourth tallest mountain in Colorado. Anyway, that's it. So it just got it wrong. I said there are only 23 data points. Why do you think there are 24 data points? So it gave us the mean, it gave us the count. Let's see, did it get it right? Now that I've corrected it, the count is 23. Well, I told it that one. It says the mean is 35.78, and that's completely wrong, man. How is it getting... Oh. Well, I tell you. It says the median's 34. That one's right. The mode is 44. The range is 37. But it got the mean wrong. The mean is 32.8. It not only got it wrong, it's way off. It did something here. I'm not really sure what this means. This thing here? I don't even know what that is. But anyway, I think it added them up and got 823 or something. But there's only 755. We know that, right? He has 755 home runs. When you add those numbers up, you should get 75. added the data points, you got a sum of 823. But the actual sum is only 755. Yeah, now it got it right because we corrected it. So we corrected it twice. That's not good. What's interesting is I gave it a different data set, because I wouldn't show you this unless I thought it worked. I gave it a different data set and I tried it and it worked fine. But for some reason, it's not working on this data set. This data set is actually smaller than I gave it a data set with 50 points, and it did it fine. So we had to correct it twice. Well, that's too bad. But anyway, be careful, I guess, when you're using Copilot to calculate descriptive statistics. It didn't tell us any quartiles or percentiles. It also didn't do the variance or the standard deviation. Those are a little harder, maybe that's why. We'll do those in the next video. All right? Till then, Professor Williams is saying, have a good day.